Hi friends, this is PH6503 Unit 2 Magnetic Property of a Material by Dr. M.R. Gadhvi. In today's lecture, we will be highlighting about the paramagnetic susceptibility of a solid substance. Till the date, we had discussed about the paramagnetism of a gaseous material or a very light material, and therefore in those cases we have mentioned about the paramagnetic gases, or the analogy with the ideal gas theory or kinetic theory of gases, and therefore the interactions are overlooked even in this, even in today's concept, that is a paramagnetic substance with the solids. It's easy to do not consider the interaction among the magnetic dipole moments, because it is mathematically resolving the situations in absence of the magnetic interactions among the dipole moments will be much easier. अगर वो आप वो कंपोनेंट ऐड कर रहे हो, दैट इज़ अ इंटरेक्शन वाला कंपोनेंट अमंग द मैग्नेटिक डाइपोल इंटरेक्शन, तो दैट इंटरेक्शंस विल बी फर्स्ट ऑफ ऑल many complexity will be increases. आप सोचो कि there are in the solid source you will be having the dipole moments in order of 10 to the power 19 to 23, राइट. अब इतने सारे इलेक्ट्रॉनिक डाइपोल मोमेंट आपके पास होंगे और ये डाइपोल मोमेंट में आप इंटरेक्शन ढूंढोगे, सो द मैथमेटिकल complexity will be enhanced a lot. So to avoid this, majority of model are overlooking the interactions among the dipole moment. Anyway, so let's assume that the neglecting of the internal interaction of a dipole moment and attempt to find it out the susceptibility. So here we are finding out the susceptibility in solid, and the concept is little bit diverted from the pure classical concept. थोड़ा बहुत हिंट दी गई है quantum concept की. Still it is not a pure quantum concept, but you can say that in a direction of the quantum concept there is a one step ahead. क्लासिकल थियरी में क्या था? क्लासिकल थियरी ये बोल रही थी कि the orientation of a dipole moment can be taken place anywhere in between the 0 to 180 degree. माने डायरेक्शन टू द अप्लाइड एक्सटर्नल मैग्नेटिक फील्ड से लेके अपोजिट टू द डायरेक्शन ऑफ द अप्लाइड मैग्नेटिक फील्ड, माने 0 से लेके 180 डिग्री में कुछ भी ओरिएंटेशन हो सकता है. बट नाउ द we are knowing that the entire magnetism is basically a quantized concept. That means the orientations are also restricted, and if the orientations are restricted, that means dipole moment cannot be always possible with the all orientations in between 0 to 180 degree. ये पॉसिबल ही नहीं है. तो ये दोनों के कंसेप्ट के बीच वाला कंसेप्ट, मैं ये तो नहीं बोलूँगा कि ये प्योर क्वांटम कंसेप्ट है, ये भी नहीं बोल सकते हम कि दिस इज़ नॉट अ प्योर क्लासिकल कंसेप्ट. सो इट इज़ इन बिटवीन, द मॉडल इज़ इन बिटवीन. Anyway, so here the idea is, so they said that let us first find it out the number of the magnetic dipole moment which is line parallel, that means it is along the direction minus 0 degree, and also find it out with the anti-parallel. Okay, so दोनों आपको find out करना है. The first make a calculation of the number of the magnetic dipole moment which are line up parallel to the applied magnetic field, और उसके बाद ये भी बोल रहे हैं कि also assume that they do not interact it, and you have to also find it out which are opposite to that, anti-parallel to that. So you will be having a two fractional quantity number of the dipole moments which are line up in this way and they are not line up in this way, that means opposite in the direction of the applied magnetic field. Spin quantum number we will be consuming as a 1/2 only. So there is just two possibility: orientation of a magnetic moment with respect to the external magnetic field. One is parallel, another is anti-parallel, राइट. सो आपके पास बहुत सारी जो सिचुएशंस थी जो पहले वाले लेंजीविन मॉडल में या तो वेज मॉडल में, वो दोनों रिस्ट्रिक्ट हो गई दो ही पॉसिबिलिटी में, करेक्ट. सो विद टू एजम्पशंस, एक आपके पास पैरेलल मोमेंट है, दूसरा आपके पास एंटी पैरेलल मोमेंट है. ओके, एंड दिस बोथ मोमेंट्स यू आर फाइंडिंग आउट. ये दो मोमेंट्स आप पैरेलल एंटी पैरेलल विथ रिस्पेक्ट टू एक्सटर्नल मैग्नेटिक फील्ड, दैट इज नंबर वन. एक एजम्पशन ये हुआ. दूसरा एजम्पशन ये बोल रहे हैं कि वी आर नॉट इंक्लूडिंग द इंटरेक्शन अमंग दिस मोमेंट्स, तो वी आर एक्सक्लूडिंग दैट. और स्पिन क्वांटम हाफ ले रहे हैं तभी तो एंटी पैरेलल और पैरेलल हो रहे हैं, ठीक है. सो लेट अस assume that we do have n number of spins per meter cube. Remember that n is now not the available number of atoms, but now it is available number of spins per meter cube. Okay, we are restricting n as a spin, तो ये याद रखना है. Okay, so the assuming in the absence of a external magnetic field, the magnetization will be zero. Now what is magnetization? Magnetization, that means the number of magnetic moment per unit volume. तो माने number of magnetic moments per unit volume, राइट. तो कितनी आपके पास n स्पिन्स तो है, माने इतने n नंबर ऑफ डाइपोल मोमेंट्स तो आपके पास है ही. तो आपके पास जितने इसमें से आप अलाइंग द पैरेलल ऑफ एक्सटर्नल मैग्नेटिक फील्ड होंगे, दैट वुड बी योर मैग्नेटाइजेशन. इट इज़ दैट सिंपल. So with this particular theory of a susceptibility, conceptually and understandability is very simple, right. So suppose out of this total n number of spins per meter cube, let us say that np, n suffix p, that is a parallel dipole moment, and na, that should be the anti-parallel dipole moment for a given temperature, for a given external applied field. Am I clear with this thing? So presumptions इतना है कि I do have a n number of moments per meter cubes, or rather the spins per meter cube. Then within this n I do have a two split, one is a parallel spin and another is the anti-parallel spin, and at that temperature T. But the rest part is still acceptable, that we are also adopting the equipartition theorem, and the equipartition theorem में proportional number will be always e to the power minus e upon kt, that everything is correct. लेकिन prerequisite condition में थोड़ा हमने modification किया है in this theory. Okay, so magnetization will be np into mu b, क्योंकि this is our spin quantum number लिया है. So per magnetic moment you have assuming that there is a one magnetic moment, तो आप given spin is equal to, you can take it up one Bohr magneton. So np mu b minus na mu b, and mu b is taken a common, so np minus na into Bohr magneton, so that will be your magnetization. Okay, so with this, and you are knowing that Bohr magneton is basically Eh upon 4 pi m, where m is the mass of the particle, rather the electrons. Anyway, so the susceptibility is given by m by h, or the relative permeability minus 1, that everything you are knowing. Boltzmann statistics we are also applying over here. Then it is obvious that the dipole moment anti-parallel to the field have a greater energy as compared to the dipole which are the parallel. क्यों ऐसा? Let us find it out. So let us say what will be the torque applied when you are switching on, क्योंकि हमने पहले तो assume कर ही लिया है कि अगर applied magnetic field 0 है तो magnetization 0 है, माने all are randomized, या तो equal number of parallel spin and the equal number of the anti-parallel spin, and therefore np minus na, that will be 0, and therefore the m will be 0. ठीक है, क्योंकि equipartition theorem है. Okay, now they said that if you are switching on the magnetic field, then you are applying a torque on this one. So they said very nice words for this. It is obvious that the anti-parallel, no, I read somewhere else. Okay, so the dipole moment inclined to at a theta angle with respect to the applied field, assuming that the energy of the dipole moment when it is perpendicular, the energy of a dipole moment will be given by this. But before that, let us say find it out the torque. Torque will be given by the mu m into b, and this is already we have done 2 or 3 times in Langevin theorem very deeply, so I am not repeating again and again. Torque is equal to basically a r cross f, and therefore you should understand it. So this is a mu b, that is your I mean mu m into b, that is your mu m, that will be equivalent of a magnetic moment. So that will be equivalent of a twice of L into pole strength. So 2Lm, and mb will be the force, and 2L is the distance between the two distance between the two poles, or the north pole south pole distance. So anyway, so torque will be calculated that way, and sine theta will be, maximum torque will be sine theta is equal to 90. So you can consider it is a mu b r cross f. So that would be rf sine theta. R is equal to twice Lm, and f is equal twice L, and f is equal to mb, and therefore it will be twice of Lm is equal to mu m, and ये आपका हो गया equation mu b s sin theta is equal to pi by 2, and that will be 1. लेकिन b can be replaced as the mu m into h. So mu 0 into h, so mu m mu 0 h हो गया. ओके, जस्ट आई एम गिविंग यू एन आइडिया कि ये ऐसा भी हो सकता है कि हमने ऐसा सोच लिया है कि वो पैरेलल ही है या एंटी पैरेलल है, बट बिकॉज ऑफ अ थर्मल एजिटेशन देयर इज सम थीटा वेरिएशंस आर देयर. सो अगर आपको फोर्सफुली यू आर ब्रिंगिंग बैक टू द पैरेलल लाइनिंग अप with the external magnetic field, so you are storing the energy, you are pumping up the energy into the system, and that why you have need to calculate the energy. So that will be mu 0 mu m h, that is your torque, into a small displacement d theta. Now here I am incorporating, यहाँ पे sin theta is equal to 1 एज्यूम कर लिया है, लेकिन यहाँ पे मैंने जानबूझ के पेन से लिखा है फॉर ईज ऑफ यू कि बेसिकली इट्स आर क्रॉस एफ साइन थीटा होता है. क्रॉस प्रोडक्ट निकालने से साइन थीटा विल अपीयर, सो आई एम कीपिंग साइन थीटा एज इट इज. एम आई क्लियर विद दिस? ओके, सो विद दिस we proceed ahead, and we are able to calculate this line of the figure. Just see how it is appears. So hence the energy with the anti-parallel dipole, that means the theta will be 180. सो अगर आप प्रीवियस इक्वेशन देखो तो ये है. सो एनर्जी, इसको अगर मैंने इंटीग्रेट किया, सो इट बिकम द माइनस कॉस थीटा, एंड इट बिकम द माइनस कॉस थीटा. सो ये हो जाएगा माइनस एच म्यू 0 म्यू एम कॉस थीटा. राइट, नाउ विद दिस you having a two condition, anti-parallel that is 180 degree, and parallel dipole moment that is a 0 degree. You substitutes either -1 or it is a 1. So you having a EA, that is the energy associated to anti-parallel, that would be mu 0 mu m h. So anti-parallel has a higher energy, positive energy, तो वो थोड़ा ऊपर रहेगा. NP is a parallel energy, it is a much lower energy, and that is minus. Energy magnitudes is same but direction are different. Okay, in a way, if you are looking very personally and minutely, then it is minus mu 0 mu m h. ओके, तो एंटी पैरेलल की एनर्जी हो गई पॉजिटिव और म्यू 0 म्यू एम एच. सो मैंने ऊपर बता दिया, आई एम सॉरी. और एन पी पैरेलल उसके कंपेयर में थोड़ा नीचे आएगा. कितना कंपेयर में नीचे आएगा? 2 म्यू एम बी. क्यों? क्योंकि इफ़ यू आर टेकिंग अ डिफरेंस ऑफ दिस टू, इट विल कम 2 म्यू एम बी. it will come 2 mu mb. कैसे? Just check it up here. EA minus EP. So EA minus EP मैंने किया. So mu m mu 0 h minus minus become plus and become 2 mu m mu 0 h. And if you are saying that mu 0 mu h as a b, so it become a 2 mu m b. Correct? And in more clarity, either it would be a 2 mu 0 mu m h, but now as we have chosen that it is the dipole moment with the single spin moment, in this scenario you can say that mu m is equal to mu b. मैंने पहले भी आपको बताया था कि अगर मैं स्पिन मैग्नेटिक मोमेंट 1/2 ही चूज़ कर रहा हूँ और पर spin is equal to 1 unpaired electron सोच रहा हूँ, then it would be a single spin momentum, that would be mu m is equal to mu b per atomic, or the magnetic moment per atom, that would be a Bohr magneton. So now it is now the pure mathematical game and we have to learn it. So anti-parallel number of spin is proportional to, according to the equipartition theorem, so that is minus EA, energy associated to anti-parallel, upon KT, or NP is equal to minus EP upon KT हो गया. So now I am doing a Na upon NP, so it become the नेगेटिव ऑफ ई ए माइनस ई पी. ई ए में इसलिए आगे रख रहा हूँ क्योंकि हमें पता है कि एनर्जी एसोसिएटेड टू द एंटी पैरेलल एनर्जी इज मोर कंपेयर टू द एनर्जी एसोसिएटेड टू द पैरेलल. सो द डिफरेंस, सो वैसे तो एन ए माइनस एन पी करोगे तो ई पी माइनस ई आएगा, लेकिन माइनस साइन नेगेटिव निकालो, तो ताकि बोल्ट्जमैन इक्वेशन का fundamental setup as it is minus E of E by KT maintain रहे, right? So minus highlight करने के लिए मैंने minus निकाला, and my satisfaction is also there, EA minus EP. Anyway, with this EA minus EP equation just we have seen in the previous relation, and that is EA minus EP is equal to, either you can write it out 2 mu 0 mu b h या तो 2 mu 0 mu m h. Let us see how they are writing as. It is mu 0 mu b h upon KT, correct? So Na plus Np, number of spins per meter cube parallel, number of spins per meter cube anti-parallel, that would be the N. So ideally what should be? Na plus N. Now divide this equation by Np, so it become Na upon Np plus 1 is equal to N upon Np. So that is what it is here. So with this I can write it out 1 plus Na upon Np माने this equation, so exponential minus 2 mu 0 mu b h upon Kt is equal to N upon Np. Right? And we modified this terminology with doing some mathematical treatment, and you can see that I am doing with the same factor at a numerator and same factor at a denominator. So mathematically I am not changing anything else, right? Exponential mu 0 mu b h upon kt, exponential mu 0 mu b h upon kt. If you look at n upon n, it is as it is. By doing this, what we are able to write it out, by we are doing this, we are able to make a common denominator in this methodology. Okay, so that is my way of doing the mathematical model. So ऐसा क्यों किया वो सोचने की ज़रूरत नहीं है, आगे 2 मिनट में आपको पता चल जाएगा, क्योंकि NP और Na का मुझे डिनोमिनेटर कॉमन रखना है. NP जैसे ढूंढ रहा हूँ वैसे ही Na ढूंढूंगा, नंबर ऑफ स्पिन्स पर मीटर क्यूब इन अ पैरेलल डायरेक्शन, तो दोनों में डिनोमिनेटर सेम आए, इसीलिए ये मैं मैथमेटिकल ट्रीटमेंट दे रहा हूँ, वरना ये भी काफ़ी है. एम आई क्लियर? Similarly, so I am going with the parallel. This is the same equation what you have. So now Na plus N is equal to N ए प्लस एन पी, अब मैं एन ए से डिवाइड कर रहा हूँ तो 1 प्लस एन पी अपॉन एन ए, एंड दैट इज़ वाई दिस इक्वेशन आई एम एबल टू गेट एन ए इज इक्वल टू दिस शेप ऑफ इक्वेशन। अगर यहाँ से देखो ध्यान से तो एन पी का डिनोमिनेटर और एन ए का डिनोमिनेटर, that you are finding the same, and that's why we are doing this mathematical jugglery. Am I clear? So na और n plus आप जब आराम से ऐड कर सकते हो. Okay, so now np minus na, the parallel minus anti-parallel, so that would be in this shape. This is the exactly shape what you have seen in the case of लेंजेविन फंक्शन एज e टू द पावर a, अगर याद है तो इक्वेशन, और वो रिप्लेस किया था हमने कॉट एच ए फंक्शन से, कॉट हाइपरबोला फंक्शन। सिमिलरली यहाँ पे टेन हाइपरबोला फंक्शन है, जस्ट कंपेयर कर लेना। अगर इसके लिए मैं अल्फ़ा सोच लूँ, सो e टू द पावर अल्फ़ा माइनस e टू द पावर माइनस अल्फ़ा अपॉन e टू द पावर अल्फ़ा प्लस e टू द पावर माइनस अल्फ़ा, दिस इज़ अ फंक्शन विच इज़ जस्ट रिप्लेसिंग द 10 hyperbola alpha, right? So alpha is equal to mu 0 mu b h upon kt मैं सोच रहा हूँ, so that is n 10 h and the same component, that is alpha. So taking the value of np minus na in the equation, one get that mu b of np minus na. Now n we are taking as a common, because np minus na, that is n 10h of alpha. So n mu b is as it is, and n minus na is equal to n 10h alpha. So n मैंने आगे रख दिया, 10h alpha is as it is. So in nutshell, magnetization will be given as n mu b 10h alpha. n mu b 10h alpha is the magnetization of a solid material, or rather a paramagnetic solid material. लेंजेविन फंक्शन में आ रहा था n rather the m is equal to ms, ms की जगह यहाँ पे म्यू भी है, सो n इंटू म्यू भी दैट इज ms. सो कॉट एच अल्फ़ा, तो यहाँ पे आ रहा है 10h अल्फ़ा। लेकिन और डिटेल में डिसेक्शन करने से पता चल रहा है कि यहाँ पे भी मेरे पास दो केस है। लेंजेविन में भी मैंने दो केस डिस्कस किए थे, हाई टेम्परेचर एंड द लो टेम्परेचर। तो इफ़ अल्फ़ा व्हाट इज़ अल्फ़ा, म्यू 0 म्यू बी अपॉन एच अपॉन के टी, तो इट इज़ द मैग्नेटिक एनर्जी टू द थर्मल एनर्जी का रेशियो है। सो यहाँ हाई टेम्परेचर होगा, सो अल्फ़ा वैल्यू विल बी स्मॉलर। हाई टेम्परेचर है तो मैग्नेटिक फील्ड की भी असर कम होगी, या तो कॉम्बिनेशन सोच लो कि लो फील्ड एंड हाई टेम्परेचर, दैट इज अल्फा इज मच स्मॉलर देन द 1। दूसरी कंडीशन कि H इज़ वेरी हाई, T इज़ वेरी लो, सो फील्ड इज़ वेरी स्ट्रॉन्ग एंड लो टेम्परेचर, तो क्या होगा, द अल्फा वैल्यू इज़ वेरी वेरी हाई, अल्फा वैल्यू इज़ वेरी वेरी हाई. So I do have a two situation, alpha is very small and alpha is very small and alpha is very high. In principle, alpha is very small, it's a high temperature case, and alpha is very high, it is a case of a strong magnetic field and the low temperature. Alpha is a very small, that means a low magnetic field and the high temperature. लेकिन ये तो फिजिकल सिग्निफिकेंस हुआ. यहाँ पे देखिए कि अगर अल्फा इज़ वेरी वेरी लो तो साइन थीटा इफ थीटा इज़ वेरी स्मॉल देन साइन थीटा इज इक्वल टू थीटा. वही 10h अल्फ़ा में भी होगा कि इफ़ अल्फ़ा इज़ वेरी वेरी स्मॉल देन 10h अल्फ़ा इज इक्वल टू अल्फ़ा. सो आपका जो इक्वेशन यहाँ पे था, मैग्नेटाइजेशन इज इक्वल टू एन म्यू बी एच 10h alpha, that become n mu b alpha, or n mu b alpha. So what is alpha? Mu 0 mu b h upon kt. So mu b mu 0 mu h upon kt वो रख दिया अपने. mu b 2 times, so it become mu b square. So n mu 0 mu b square h upon kt. If you do remember the high temperature zone of a Langevin theorem, it is exactly similar, only that with a n mu m square mu 0 h upon kt, rather 3 kt, and therefore I am able to write it out that this is the difference between a Langevin theory and the two-stage quantum conceptual theory of a solid material for a paramagnetic system. And here there is a difference of a factor 3, and here there is a difference of a factor 3. So you can see अगर Langevin function आप देखोगे तो यहाँ पे 3 आएगा, ठीक है. And if you are bringing up this h at the bottom of m, तो it become susceptibility. फिर से बता दूं, अगर ये h है वो यहाँ पे ले लो तो m by h हो गया, so that will be your susceptibility. So that is the chi is equal to m by h. So it's basically a volume susceptibility, and mu 0 mu b square n upon kt. So you can compare the Langevin functions and the two-stage quantum concept for the solid particle paramagnetism theory. There is a factor of a 3 is a variations of the factor 3. I think rest part is same. Yes, here mu b is replaced just Lende factor and the magnetic quantum number has introduced, so that is just expression of the susceptibility in other way. So it is written like this: g is equal to 2 and j is equal to 1/2. So if you square, make it j square and g square, so it become a cancelled out to each other. So basically you are mentioning here g square j square, or this equation is identical, right? This is 4, this is 1 by 4, and it will get cancelled. So numerator will be remain as it is, as you have speculated. So it is also supportive to the pure quantum concept till up to certain level, and you can draw the curve. It is exactly similar to the Langevin function. You are getting the initial part is just like the linear behavior, and at a higher field and lower temperature it is about to saturate, and this is almost equivalent of a 10H alpha, right? Or the slope will be parallel to the unity. So yes, you can look at here also. It will be when you draw a line like yeah, so this is a kt, so this is a mu 0 and mu b by k, so that is your slope. So y is equal to mx, c is equal to 0, so because it's passed through this one. So chi, that is m by h, so chi is a y, mx is 1 over t is a x, so the slope will be mu 0 and mu b square by kt. So you can look at here. So this is your m by ms, or you can say the m by ms. So n into mu b, if you shifted here, so it become m by ms, magnetization by saturating magnetization. So that is m by ms is equal to mu 0 mu b h अपॉन के टी. एक म्यू बी और एक एन वो एम एस में चला गया, सो एम अपॉन एम एस. फिर से देख लो आप यहाँ से, एक म्यू बी और एक एन, दैट विल बी शिफ्टेड टू हियर, सो एम अपॉन एम एस. ये एच में वापस ले रहा हूँ ऊपर, सो म्यू 0 एन एच म्यू बी अपॉन के टी, दैट यू कैन लुक एट हियर, म्यू 0 म्यू बी h upon kt, n and 1 mu b will be go into ms. So m by ms versus alpha का ग्राफ ड्रॉ करोगे तो it will pass through the 0, that means y is equal to mx plus c में c will be, intercept will be 0. So if you take a slope will be equivalent of mu 0 mu b h upon k, and it's about to be a unity. Okay, and this is very much true for many of the samples like a liquid as well as the solids. The this is giving you quite better results. in context to the previous one. If you look at this is C is equal to mu 0 mu b square n upon kt, so it also satisfies the Curie constant conditions, and this relation is known as a Curie law. With this I am stopping here. Do best in your exam, all the best. So till this point, this is your theory portion of the CIA2. Stay home, stay safe, good luck.